Yes, good day, class. Thank you once again for tuning on Metric Hub. I'm bringing to you today natural sciences grade 9. As you all know that we need to prepare for end of year exams, we need to pass, we need to get distinctions. So we try by all means to make comprehensive revision. Follow this paper that is posted on the board. It is a provincial paper from Gauteng, 2021. So I'm just going to work with you all the questions that are in here, and then you get the memo comprehensively done for this whole paper. So let's go through it without wasting any time. You can see that this is grade 9 2021. It is 2 hours paper. It is November. You can as well see that the paper is actually 2 hours and it's 100 marks. So please just check through. I'm not going to go through instructions, but anyway, when you are going to write your exams, always make sure that you read the instructions. You can see that you answer all questions in the question paper. This question paper consists of section A, B, and C based on prescribed content framework in the CAPS document. Allocation of marks, section A is 20 marks, B 40, and C 40 marks. This question paper consists of 10 questions. Follow the instruction and the numbering for each question. Write neatly and legibly. I just thought of reading them just for others to remember. And anyway, don't forget to write your surname, name, and class on the question paper, please. Please don't forget to write your names. Don't forget to give your names there on the paper when you write exams, as well as the name of the subject. Anyway, you need to know that it's section A. You are writing, you are only going to, like I said, you need to follow instructions per question. So we are given various options, and then as possible answers to the following questions. You choose the correct answer by cycling or replacing a cross over the correct letter A to D. So for me here, what I'm going to do is what this question means. It means on each number, you're going to circle the number. You circle the letter, sorry, that is correct for each question. So let's quickly go through it. Number one, a field force dash. If you can refer on our notes on the channel, I did these types of forces. They are posted also. So for the sake of revision, I'm not going to take more time. Let's quickly just answer the questions, and then additional notes and explanations will come separately because the paper is long. So we need to cut it short. A field force dash A is always a force of attraction. B occurs only between magnetic and electrical charges. C results in an action of a distance between two bodies. So D is the only type of force that is able to change the speed of an object. Number one, it results in an action. It results in an action over a distance between two bodies. A field force results in an action over a distance between two bodies. That is C, number one. And then question number two, I just want to change my pen quickly. Question number two, in which of the following diagrams are the voltmeter and ammeter connected incorrectly? Which ones are in which of the following diagrams are the voltmeter and the ammeter connected incorrectly? I also remember we did electricity and current. So I was saying, please make sure that whenever you are given these diagrams, you need to understand the proper representation of the various symbols. Is for the cells, it's for the voltmeter, is the ammeter, and also the resistance and so forth. So what I'm saying is that what you need to understand here is that the proper diagrams, you need to understand to say, in this case, which of these diagrams are showing the following instruments that are incorrectly placed or incorrectly connected. So as you can see, we are saying there should always be an ammeter that reads through the current and also the voltmeter, the torch cells. So in this diagram, as you can see, we are saying our ammeter and so forth our answer is what? Is B. B is incorrectly uh put into connection. B represents the incorrect representation. So what we are saying is that if you can check AE, we have got our torch cells, we have got our ammeter, which is measuring the current there, and then we've got the voltmeter, which is measuring the voltage, and then obviously the torch cells, we are saying they are correct. So what is happening is answer is B in terms of question 1.2 based on the diagrams there. You can as well refer on the notes on various diagrams that are posted there. In all the conductors, if all the conductors are made of copper wire, which one is the greatest resistance? If all the conductors are made of copper wire, which one has the greatest resistance? So in terms of question 1.3, the greatest resistance will be found on what? On the long, thin, and what? Our answer is what? Is A. Number 1.3, the greatest resistance, if the conductors are made of copper wire, it is the one which is long, thin, and hot. That is the correct answer in terms of question number 1.3. And then the crust in the uppermost part of the mantle together form the dash. The crusty, the crusty, it is the crusty, the uppermost part of the mantle together form the dash. It is forming the lithosphere. I'm sure that you remember that when we look uh, on this question, you always need to understand the representation of the various spheres. And then I'm saying the lithosphere is made up of the crust and the upper part of the uppermost part of the what? Of the mantle together, they form the lithosphere, which is number B. Are we together there? Next question. A natural solid, a natural solid with a definite chemical composition and a specific crystalline structure is called dash. As natural solid with a definite chemical composition, it has got a definite chemical composition and specific crystalline structure. It is called what? It is called a mineral. A mineral is the what? Is the solid, it's a natural solid with a definite chemical composition and a specific crystalline structure. It is a mineral. Which of the following gases is a greenhouse gas? Which of the following is a greenhouse gas? If you refer also on the channel, we talked about the methane, which is a gas that is produced from dumping site or decomposing matter. So methane is produced as a greenhouse gas that is also heavily contributing in terms of our greenhouse gases in the atmosphere. So the answer is what? Is D. What is the difference between a series circuit and a parallel circuit? I also presented on the channel number 1.2, number 1.7, the difference between a series circuit and a parallel circuit. What is the difference? Number 1.7, it is that a series circuit has one path and a parallel circuit splits into branches, which is correct to say that A is the correct answer on number 7. It is A. A series circuit has one path and the parallel circuit is split into branches. If you can remember the connection of cells or the connection of bulbs in a what? The connection of bulbs in a parallel and a series circuit. I'm sure that you remember those are different pathways that are there. So a series circuit has got one path and a parallel circuit, it is split into branches depending on whatever the way it is aligned. Number 1.8, generating electricity by falling water is called what? It is called what? Obviously, electricity that is generated from water, it is called hydroelectricity, which is letter what? Which is letter B. So number 8, electricity generated from falling water where it hits the turbines and then this and that, we call that generation of electricity. It's called hydroelectricity. It's called hydroelectricity. The terminology question 2, terminology, which is terminology Give the correct scientific term for each of the following descriptions. Write only the term in the spaces provided. So we just need to write the answers in the spaces provided here. The SI units of force, the SI units of force is called what? It is called Newton. Force is measured in newtons. Newton is the SIU, the standard unit measurements for what? For force. Standard SI units of force is called Newton. And then a solution that conducts electricity, it is called an electrolyte. An electrolyte is a solution that conducts what? That conducts electricity. Electro is called electrolyte. A solution that conducts electricity is called an electrolyte. That is very correct. A component that opposes the flow of current in an electric circuit, what is it called? A component that opposes. I'm saying if you look on the structure of this previous question that we were talking about, the circuits and stuff. So a component that is found in an electric circuit that opposes the flow of current, it is called a what? A resistor. It is a resistor class. A resistor, it actually opposes the flow of current in a what? It actually reduces the amount of electricity that is circulating through a what? A circuit. A rock in which a mineral is concentrated. A rock in which a mineral is concentrated. I'm sure we have heard of the ores. We talk about it as an ore. An ore is a rock in which mineral is concentrated. An ore. The increase in the average temperatures of the atmosphere, it is called global warming. It is called global warming is the increase in average temperatures of the in the atmosphere, which we also discussed last time that it is contributed as a result of what human impact to the environment, contributing immense gases or greenhouse gases that are accumulating there. And then we need to understand that global warming results in what in flooding of coastal places and other things. Just take note of this because in any case you must understand it's a current trend that needs to be understood in the concept of now. And then number 2.6, it is the explosion of massive star. The explosion of massive star, we call that what? It's called supernova. Explosion of a massive star is called supernova. Explosion of a massive star is called supernova. It's called supernova. So please, let's keep in touch and then don't lose this. I have tried to increase the font of my body so therefore everyone can see clearly. So please don't miss any question, and where you don't see, try to uh, follow properly and then you don't get the answers wrong. We go to question 3, matching columns. You make the statement in column A with the correct concept in column B. Write only letters A to H next to the question number. That is 3.1 to 3.6 in the spaces provided. Write only the letter. Write only the letter which matches the correct, which gives the correct answer from the following. So we are given that a surplus of electricity when voltage is 110% above the normal average, above the normal voltage in the power line. What is it called? What is it called? You see, of course, the table can be there, but in any case, you need to know these terminologies, so therefore you can be able to to understand them very clear and smart before even you read to the terms that are there. You can as well know the answers by your head to say which is it, and then you just look for the answer on the what on the options provided. So surplus of electricity when voltage is 110% above the normal voltage in the power line, we call that what? Power surge. It's called power surge, which is letter C. And then a system that generates electricity A system that generates electricity is a power station. It's a power station, which is H. Power station generates electricity. It's a system that generates electricity. It's H. And the instrument used to measure current strength. An instrument used to measure current strength. We measure current strength by what? By an ammeter, which is letter B. An ammeter is used to measure. I'm saying it's an instrument that is to measure the strength of current. Pulling pulling force that bodies exert on each other over that exist over, I mean, pulling force that bodies exert on each other over a distance due to their mass. Number 3.4, we call that what? Pulling force that bodies exert on each other over a distance due to their mass. We call that what? It is called gravitational force, which is letter A. It is called gravitational force. Gravitational force is the pulling force that bodies exert on each other over a distance due to their masses. Is gravitational force. 3.5, the sphere in which weather occurs. The sphere in which weather occurs. Whether it occurs in the sphere what? It is in the troposphere, which is letter E. Which is letter E. And then the last question, number 6, magma magma that is kept to to the surface of the earth, it is called what? It is called lava. I'm thinking and agree that you remember the issue of volcanic eruptions. We call that what? Lava that escapes or that erupts to the surface of the earth is called lava. Molten magma, which is what? Which is actually caused because of volcanic eruptions. Remember, because of the compressional force underneath the Earth's crust, we have got the molten magma. That is which we call lava when it erupts or when it escapes to the surface of the Earth. And then next question, it is section B, state, energy and change. Force, we just want to quickly answer this. State two effects of force. State two effects of force. I'm also just going to quickly answer and I can as well give additional answers. State two effects of force. Force, it can also, force can cause an object to do the following. Force, force uh, can, force can cause an object to do the following. Force can cause the object to do the following. One, it can cause an object to rotate. An object can rotate due to force. An object can rotate due to force. It can cause an object to change direction. To change direction, an object can change direction because of force. We can also say that force can change, can also affect an object by causing an increase in speed. That is to speed up. Force can also be used to change the shape of an object. It can also be used to change, can also change the shape on to change the shape of an object. So what we are saying is that force can cause an object to do the following: to change the shape, to change direction, to speed up, to rotate. These are some of the things that the force can do. Force can do the following when when it is applied on an object. So it can do the following that I have listed there. Identify the type of force that is exerted on the following. a rubber band that is stretched. When a rubber band is stretched, I'm sure that you remember that you can as well just try to practice it even when you are writing there. It is what? It is tension force. It is tension force. And then squeezing toothpaste, squeezing toothpaste from a tube. We do what? That is also what? Stating that identify the type of force that is exerted. It is compression. When we are to take toothpaste from a tube, we compress it. The tube is compressed. It is compression and also stretching of a rubber band. It is by what? It is causing tension. I'm sure that we are still together here. And then the next question, 4.3. 4.3 start the photographs below which illustrate the magnetic field between bar magnets and answer the following questions. We have got photograph A and then we have got photograph B, which are all shown on the what, which are given on the board here. So let's quickly just identify the force holding the ion filings in place. Identify identify the force holding the ion filings in place. That is question 4 point what? The force that is holding the ion filings in place. I'm sure that you can see this question is to do with magnetism. So it is what? It's magnetic force. That is 4.3.1. It is magnetic force. I'm sure that you can see that these are ion filings that are holding or that are attaching to a magnet. So the force that is holding the ion filings in place is magnetic force. It is magnetic force that is acting here. And then briefly explain your observation in photograph A, in photo A and in photo B. So let's start with photo A. Photo A, what you can see is that the magnetic field are attached. We can see in photo A here, photo A, what we can say is that photo A, magnetic fields are attracted at the poles as a result of what? As a result of strong forces of unlike forces. I'm sure that we can see this is just magnetism that is being illustrated. So we are saying in photo A, the magnetic fields are attracted at the poles as a result of what? Of strong, as a result of strong forces of unlike poles. That is what is happening in A. You can see they are attracting each other there. So we can say that A, magnetic fields, magnetic fields are attracted at the poles, are attracted at the poles as a result of what? As a result of strong forces of unlike poles. To poles as a result, as a result, as a result of strong what? Forces of unlike poles. As a result of strong forces of unlike poles. That is what is happening in A. Magnetic fields are attracted at the poles as a result of strong, as a result of forces, as a result of forces that are strong, or as a result of forces of unlike poles. We can say as a result of strong forces of unlike poles. There is strong, of course, here as a result of strong, as a result of strong, as a result of strong forces of unlike poles, as a result of strong forces of unlike poles. That is what is happening as a result of strong unlike poles, strong forces of unlike poles. That is what is happening in A. Strong forces of unlike poles are causing the what? The magnetic forces or the magnetic field to be attracted at the poles, as you can see. And then we can say B. Let's talk about B. If you can look at B there, also photograph B. What is happening in photograph B again, we can as well understand that the magnetic field in B, the magnetic field that is in B here, we can also, that magnetic fields repel each other at the poles as a result of what? Of weaker forces at the, weaker forces at the like poles. I'm sure that you can see the forces are repelling. They are repelling forces that are being illustrated in B there, which is as a result of what? Which is a magnetic field that shows repelling forces from each other at the poles as a result of weaker what? Forces that are at the like poles. Like poles, they don't attract, but they repel each other. That is exactly the concept that you just need to explain in B. So B, we are having magnetic fields, magnetic fields. The magnetic fields actually repel each other, repel each, they repel each other at the pole. They repel each other at the pole, which is as a result, they repel each other at the pole as a result, which you can see as a result of weaker, as a result of weaker uh, forces at the like poles, as a result of weaker forces that are at the like poles. That is the concept that you are supposed to take note of in this, in respect to diagram A and B. So B, we have got repelling forces, which is taking place at the poles as a result of what? Weaker forces at the like poles, that is taking place at B. And then at A, we have got magnetic fields are attracted at the poles as a result of strong forces of unlike poles. You can see they are attracting each other here in what? We are saying there is attraction in A, and then there is what? There is repelling. They are repelling because they are what? They are like, they are like poles here. And then attraction is a result of what? Strong forces of unlike poles. That is taking place in what? In what? In A. In A, we are saying attraction as a result of strong forces of unlike poles. There is repellence of magnetic fields are showing repellent because they are like poles. Therefore, there is a weaker what? There is a weaker. There is, we have got to have that to see that there is it is as a result of weaker forces that are working against each other there. So that is what is happening in question 3.24. 4.3.2. Next question, our next question is name two other non-conductive forces besides the force mentioned in 4.31. Mention name two other non-conductive forces besides the forces or the force mentioned in 4.31. So 4.31, we are talking about what? Magnetic force. So another force which we can mention there, which is in question 4.3, other two non-conduct besides the force mentioned there. So we can talk about what? Electrostatic force, one, electrostatic force, and then two, we can also talk about gravitational force. There are two other examples of what non-conductive forces besides the force that is mentioned above there. So we have got gravitational force and then electrostatic force as two other examples of non-conductive forces besides gravitational force, electrostatic force, and gravitational force. Uh, let's go to the next question. Question 5.1. Question 5.1. Question 5.1, there is also the circuit diagram. All the light bulbs are identical. All the light bulbs, all the light bulbs are what? Are identical, meaning to say they look alike. All the light bulbs, they look alike. This is what is shown here. And then our first question is saying 5.5, I mean 5.1.1, if the voltage of one cell is 3 volts, if the voltage of one cell is 3 volts, determine the voltage of the battery. It is equals to, obviously we are saying if the voltage of one cell is 3 volts, and then determine the voltage of the battery. This is equals to what? This is equals to 3 times what? 3 times 4. We need to say that that is 1, 2, 3, 4. We are saying there are 4 batteries. If the voltage of each cell is 3, determine the voltage of the battery. So we are saying each cell has got 3 volts. So we have got 1, 2, 3, and then 4. So we have got four cells. And then each cell, we have got 4 cells. There are 4 cells, therefore there are 4 cells. So this question determines the voltage of the battery. The voltage of the battery, this is equals to what? This is equals to 3 volts. 3 volts times 4. And then we can get this is equals to 12 what? 12 volts. As to say, determine the voltage of the battery is equals to what? Is equals to 12 volts. Because I'm saying we have got 4 cells there, and each cell is got 3 volts. So you just multiply 3 times 4. State with a reason what you know about the current through light bulbs. I mean, state with a reason what you know with a reason, class, with a reason what you know about the current through light bulbs 2 and 3. Through three, I mean, state with the reason what you know about light bulbs 2 and 3, which is question. I'm saying 2 and 3. State with the reason what you know about the light bulbs, what you know about the light, about the current that is through the light bulbs 2 and 3. So one thing that is there is that the current through the light bulbs 2 and 3 are equals to what? To each other, because they are connected in what? They are connected in parallel. As you can see, they are connected in parallel. They are therefore, what we are saying is that the current through light bulb 2 and 3, the current through light bulb 2 and 3, we are saying that are equal to each other because they are connected in what? In parallel. So the point is that current through the current the current that is through the light bulbs, the light bulbs, the light bulbs 2 and 3, 2 and 3, are equal to each other, they are equal to each other, as you can see there, because they are connected in parallel. That is what we know about light bulb 2 and 3. So what we are saying is that the current through the light bulbs 2 and 3 are equal to each other because they are connected in parallel. That is what we know about those light bulbs 2 and 3, which you are seeing here. The current that is flowing through each of them is equal to each other through those bulbs is equal to each other because they are connected in what? They are connected in parallel. Compare the light current uh, compare the light current question 5.3.1. Compare the light compare the current through light bulb 1 with the current through light bulb 2. Compare the current through light bulb 1 and light bulb 2. So in this case, what we are saying is that it will continue to shine. The light, compare the light bulb through light bulb 1 and 2. We are saying compare 1 and 2. So we are comparing this. So what the question is like, what we need to say is that the current through the light bulb 1 is what is higher than the current through light bulb 2. The current through light bulb 1 is actually higher than the current that is through light bulb what? Than the current in bulb 2. That is what we are seeing there, as you can see. The current through light bulb 1 is higher than the current in light bulb 2, as you can see there. The current through light bulb 1 is higher. Light bulb 1 is higher. It is higher than the current in bulb 2. It's higher than the current in bulb 2. That is what is the question saying. Compare the current through bulb 1 with the current through light bulb 2. So current through light bulb 1 is higher than current in light bulb 2. That is the comparison that you can see in question light bulb 1 and 2. This one, it is actually having a higher current than bulb 2. That is what the question wants you to do, the comparison. And then question 5.4, if light bulb 1 blows, if light bulb 1 blows, what will happen to light bulb 3? Explain your answer. If light bulb 1 blows, what will happen to light bulb what? That is question 5.1.4. If light bulb 1 blows, we have got our light bulb 1 here. I can maybe just try to illustrate. We have got light bulb 1 here, and then we have got light bulb 2. We have got light bulb 2 there, and then we have got light bulb 3, which is like that. So we have got 2, and then we have got 3. We have got 1 there. So the question is saying, if light bulb 1 blows, what will happen to light bulb 3? So if 1 blows, which is this one, if this one blows, what will happen to question what? To bulb 3? That's what the question is asking. So in that case, what you need to understand is that light bulb 3 will go out of, we are saying light bulb 3 will go off because bulb 1 is what is connected in what? In series. So if actually it blows, there is a gap in the circuit there. As you can see, bulb 1, it is coming from our what? From our torch cells here. If you can draw this diagram, we have got one where we have got our torch cells, which are given here. We have got our torch cells that are what? that are given there. And then what we are saying is that if light bulb 1 blows off, bulb 3 will also blow off, because what happens there is that bulb 3 will also blow off because bulb 1 is connected in series. So obviously if it blows off, there is a gap in the circuit that will be found there. That is actually the reason. So question number 3.1.4, we are saying uh light bulb 3, light bulb 3, which is that one, will also go off. It will go off also. Light bulb 3 will go off uh because what is the reason? Because bulb 1 is connected. Bulb 1 is connected, in series. Bulb 1 is connected in series. So if it blows, there is a gap in the circuit. So if it blows, so if it blows, there is there's gonna be there's a gap in the circuit. So that is why you see bulb 3 going off also. Bulb 3 will go off because bulb 1 is connected in series. So if it blows, there is a gap in the circuit which is causing that bulb what? It means if it blows here, bulb 1 blows, it means it is cutting off somewhere here. So when it cuts off somewhere there, electricity cannot go to bulb 3. So that is what is happening with what? With the bulb what? With the bulb 3 there. That is what is happening with the bulb 3. And then let's just quickly go to the next question. Next question, if bulb 2 blows, light bulb 3 will continue to light. Give a reason for the statement. I'm sure this we have already given, also similar to the statement that we have given there, to say if bulb 2 blows off, if this one is off, if bulb 2 blows, bulb 3 will continue to light. Give a reason for your statement. Actually, it will continue to shine or to burn because bulb 2 is connected in what? In parallel. And then, so if it blows, there is still a path in which the current can flow. That is actually what is happening with regard to what? To this statement. So bulb 3, it will continue to shine. Bulb 3 will continue. Bulb 3, it will continue to burn or to shine. Because the bulb 2 is connected in what? Because they are connected in parallel. Because bulb 2 is connected in what? In parallel. So when they are in parallel, what you need to understand is that there is still a pathway. Because there is still a pathway, even if it blows off. So if it blows, ne, there is if it blows, there is still a path. There is still a path in which the current can flow. There is still a path through which current can flow. Through which current can flow. So that is the reason that is happening with that question. If bulb 2 blows, it doesn't affect bulb 3 because they are connected in parallel. So if it blows, if bulb 2 blows, there is a pathway through which current can still flow. That is the reason which is causing bulb 3 to remain lighting. Mention any two factors that affect resistance in a circuit. Any two factors that affect resistance in a circuit. One, we can talk about length of the conductor. Length of the conductor. Length of the conductor. Two, it can also be type of material. Type of material can also affect resistance. It can also be thickness of the conductor, which can also affect the thickness of the conductor. Thickness of the conductor, sorry. Factors that affect the resistance. And then also it can also be temperature of the conductor, which can also affect temperature of the conductor. So these are various factors that can affect resistance in a circuit. Length of the conductor, type of the material, thickness of the conductor, temperature of the conductor. I'm sure if you can remember also from the previous question that we did before, you can relate and see that there is a question also which was asked with regards to say if the conductor is made up of copper, which statement can be correct. You remember that previous question that we did there. So length of the conductor, type of material, thickness of the conductor, as well as temperature can affect resistance in a circuit. So I'm sure you can get this very well and smarty. Next question. It is electricity generation in South Africa. Electricity generation in South Africa, which is actually one other question. Read the text below and answer the questions that follow. Nuclear fission. Sorry. Nuclear fission is the release of energy that occurs when a radioactive element such as uranium is split into other atoms. And then South Africa's main coal reserves are concentrated in Mpumalanga because moving coal electricity over long distances is inefficient. It was decided in mid-1970s to build a nuclear power station at Koppang near Cape Town in the Western Cape. A nuclear power station uses radioactive fuel, usually uranium that is 235, which is placed in a reactor. Nuclear waste is radioactive because the splitting of uranium atoms also releases gamma radiation. These gamma rays are similar to X-rays and can cause burns, cancer, and genetic mutations in living things. They can only be slowed or stopped with thick walls of concrete, lead, or packed ground. It is therefore very important that nuclear waste is disposed of correctly, so that it does not contaminate the environment to harm people. That's how the essay or what the essay is saying. So our first question is saying, explain why Kopeng Power Plant was built in Western Cape. Why was it built in Western Cape? We can see there the statement is saying uh, South Africa's main coal reserves are concentrated in because moving coal and electricity over long distance is inefficient. It was decided that they build nuclear power station, this one, which is in Cape Town near Western Cape. So our answer is what? It's because there are no coal reserves in Western Cape. Because there are no coal reserves in Western Cape. because there are no, we don't have core reserves in what? In Western Cape. That can one be one reason that we can give there. It can be one reason that we can give there. And then the next question is saying, which element is used in nuclear reactors? Which element is used in nuclear reactors? I'm quite sure that we have read of the uranium all over the statement there. We are saying nuclear power station uses fuel and also uranium is used. Uranium, uranium is used. Uranium uranium is used, which element is used? It is what? It is uranium, which is used in nuclear reactors. And then what health problems are associated with nuclear waste? These are quite a lot of them we can talk about. They are mentioned. Uh, they can cause burns. They can release gamma radiation that are similar to X-rays and can cause burns. They can cause burns, cancer, genetic mutations. They can only be slowed by what. So what we are saying is that the what health problems are associated with this. One, there are quite a lot, as I've mentioned there. The nuclear waste can cause burns, can cause it can cause burns. Two, it can also uh, cause cancer. It can cause cancer and also genetic mutations. So questions such as this one's class, their answers are given in the what? In the essay. They can cause genetic mutations. The answers are given in the essay as you can see there. So nuclear waste can cause burns, cause cancer, or genetic mutations. I'm saying the answer are found in the essay there. 6.2, the table below indicates the alternative source of power generation in South Africa. Fill in the missing information on the lines provided there. 6.2.1, we are saying fill in the missing fill in fill in the missing information on the lines provided below. So we have got 6.2.1 dash Heliostat focus the sun's rays energy on a collector tower, and then renewable, it is a type of energy, it is renewable, advantage is not there. So 6.2.1, we can talk about uranium. Uranium, it is the first, it is actually the one that description that has got heliostats, focuses the sun's rays on a collector tower, and then it is renewable source of energy. Advantage of it has no air pollution. There's no air pollution. That's the advantage that we can give there. And then next question, it also 6.2.3, dash water. We have got dash, it is water in dams or pumped storage is released and fall onto turbines connected to generators to produce electricity. 6.2.3. Sorry, 6.2.3. So actually here, let me just correct something quickly. We are saying 6.2.1 We are saying it is the what? Sorry, it is it is actually the solar energy. Solar energy, or we can just say the sun. It is the sun that actually uses the focus the sun's energy on a collector tower, and then it has got what? It is a renewable source of energy. Sorry, it was just a misreading of the statements there. So it is solar energy, and then it is actually the advantage is that has no air pollution. That is advantage of the solar energy. And obviously the other advantage, as it is said, it is renewable. We can also give it as an answer. 6.2.3. So we are saying it is what? It is water. It is water. That is, we are saying water, and then the description renewable or non-renewable, it is what? It is renewable energy. It is a renewable source of energy. And then 6.2.5 sea waves. And then the sea waves, in terms of description, the sea waves, what is the description with the sea waves there? The sea waves, 6.2.5, how do they work? We are saying what we need to understand is that there is up and down motion of waves uh, that can be converted into what? Into electrical, that can be converted into electrical energy. Number 2.5 sea waves, there is up and down motion. There is up and down motion of waves. Of waves that can be converted into electrical energy. Of waves that can be converted into electrical energy. Into electrical energy. So the description is that there is up and down motion of waves that can be converted into electrical energy. And then in terms of renewable or non-renewable, it is renewable. Obviously, there is no air pollution on that. Number 7. Number 7, energy released when an atom splits to heat water to produce water, and then non-renewable and no air pollution. So 2.7, 6.2.7, we can talk about what? The radioactive element. Radioactive what? Element. Radioactive element, uh, energy released when an atom splits to heat water to produce power, and then that is what it is in terms of those descriptive statements. Let us quickly just go to the next question. Next question. Next question. So I've been just writing the answers on the spaces because I just didn't want to move up and down. So I just wrote the answers on the spaces there. So it is well. It is well as it is there. We can go to the next question. Question 7. Cost of electrical power. The following table shows the energy usage of various household appliances. So we are given that the following table, it shows the energy usage of various household appliances. Household appliance energy use in what? The stove has got 2000 watts, iron has got 450, geyser 3000, TV 700, and then laptop 50. So which component uses the least amount of energy from the above table? This one, we cannot want to think, we just see, we just look. The list which has got the lowest amount of energy used, it is what? It is the laptop. It is the laptop that is given there. Laptop, it uses the least amount of energy that is given on the question. List two ways of reducing the amount of electrical energy used by the geyser. How can the amount of energy used by a geyser reducing amount of electrical energy that is used by geyser? So what can we do? You can also, one, you can use a geyser blanket. Use, use a geyser blanket. Can say use a geyser blanket as number one. Two, what else can we say? Use a geyser timer. We can also use a geyser timer. Use a geyser timer that can also work there, and then switch the geyser on and off when required. It can also help to, I think you have seen even on our SABC that it always talk about switch off all unnecessary appliances. So uh switch the geyser on and off as when required. Switch the geyser on and off when required. They can help to reduce the amount of electrical energy that is used by a geyser there. Question number 7. Electricity is sold at approximately 60 cents for a kilowatt. It is sold approximately 60 cents for a kilowatt. Use the information to calculate the cost of electric energy of the stove oven if it is used for 3 hours uh, a day. If it is used for 3 hours a day. So cost of energy, here we can just say cost of energy is equals to, we have got our power, we can say it is equals to our power rating multiplied by time, multiplied by what? Multiplied by cost. So we can go down and then we say that if it is given that it is used, calculate the cost of electricity, of electric energy of the stove oven if it is used for 3 hours a day. If it is used for 3 hours a day, so we have got to say our cost of electricity is equals to, we just multiply, that is equals to 2 times 3 times what? The 3 hours a day, because it's saying it is approximately for a kilometer, for multiplied by what? By the cost, which is what? Which is 60 cents. Multiplied by 60. This is 60 cents. Obviously, when we multiply that, we can get that is equal to 360. 360 cents is what you get, which we can give to say total cost. Total cost is therefore equals to, we can just convert this into what? Into rands, or into rands. Yes, this is equals to 3 rand 60 cents. 3 rand 60 cents is going to be the final answer that we can get. The 3 rand 60 cents is what you can get in terms of this, because we are given that the cost of using what? calculate the cost of electric energy of the stove if it is used for 3 hours a day. So we get that, and then we get our total answer, or our answer is like given there based on the formula that we are given again. So let's just go to question number 80. Earth and beyond. Earth as a system. The diagram below illustrates the interaction of the sphere of the Earth as a complex system. I once said that you cannot also go to final exams without understanding the sphere of the Earth. So, question number 8.1, describe the interaction of the different spheres. You are given this diagram there. So you are supposed to describe, we are actually supposed to describe the interaction of the various spheres. So we are having our lithosphere, our atmosphere. We also have our biosphere, and also the issues of to do with the plants and oxygen release there. We also talk about the hydrosphere in terms of the water evaporation from oceans, and also being into water vapor in the atmosphere is actually what we need to discuss about in this statement. So I'm just gonna describe actually the interaction of the different spheres. So the question wants us to describe the interaction of the different spheres. So the lithosphere and the hydrosphere, we have got one, we have got the lithosphere and hydrosphere. The lithosphere and hydrosphere, we talk about here, what is the describe the interaction. Water erodes the soil. Here, water erodes the soil. Between the lithosphere and the hydrosphere, water erodes the soil. Describe the interaction of the various spheres. Here, water erodes the soil. And then we think about the atmosphere and the hydrosphere. And the atmosphere and hydrosphere. The atmosphere and hydrosphere. Here, what you need to understand is that water evaporates from the oceans, becoming what? Becoming water vapor in the atmosphere. Water evaporates. Water evaporates from water bodies. It evaporates from water bodies, becoming what? Becoming water vapor in the atmosphere. From water bodies, becoming water vapor. It becomes water vapor in the atmosphere. Water vapor in the atmosphere. Water, it evaporates from oceans and so forth, and then it becomes water vapor in the atmosphere. Number 3, we can also talk about the lithosphere and atmosphere. Lithosphere and atmosphere. Lithosphere and atmosphere. What happens again is that volcanic erupts, shooting gases and what, and dust into the atmosphere. We have got volcanoes. We have got volcanoes erupt. When volcanoes erupt, they do shooting gases. They shoot gases and dust into the atmosphere, shooting gases and dust into the atmosphere. And then we have got also the biosphere and the atmosphere. Because here we need to explain the interaction, the biosphere and the atmosphere. Plants give off oxygen during photosynthesis. Plants give off oxygen during photosynthesis. During photosynthesis, plants they give off oxygen. I mean, during photosynthesis, and then plants give off oxygen during photosynthesis, and then and and also use and also they use what? Use carbon dioxide and use carbon dioxide. They give off oxygen during photosynthesis and use carbon dioxide during the same process. We might also just need to comment about we are saying here is the biosphere and the atmosphere. We can also talk about the biosphere and the hydrosphere. Biosphere, uh, biosphere, biosphere and hydrosphere describe the interaction, the biosphere and the hydrosphere. Water is used by plants and animals here. Is used by plants and animals. I'm sure that you know that water is needed by plants to grow, and then animals they also drink water there. And then let me just lastly talk about the biosphere. Biosphere and what? And lithosphere. The biosphere and lithosphere. Plants drives water from the soil and animals use what? Use water to sustain life. Plants, plants, they drive water from the soil and also animals use what? Use water to sustain life. Sustain what? To sustain life. These are the interactions because the question wants you to say, describe the interaction between the various spheres. The question wants you to say, describe the interaction of different spheres. Describe the interaction of the different spheres that are shown as by what? By this diagram there. So we have got the interactions. You need to relate each of them and try to show how do they relate. Lithosphere and atmosphere, volcanoes erupt shooting gases and dust into the atmosphere. We have got also the biosphere and atmosphere. Plants give off oxygen and take in carbon dioxide during photosynthesis. Those are the various interactions as I've just explained them there. So please take note, and then we can as well want to talk about the next question. Complete the diagram of the rock cycle below by filling in the stages labeled 1 to 5. The rock cycle by filling in the stages labeled 1 to 5. 1, 2, 3 is a rock cycle. The question wants us to complete the stages. This it is a rock cycle. Fill by filling in the stages 1 to 5. Fill in or complete. So 1, I can see that we can agree that this is igneous rock. It's igneous rock. And then 2, we can have sedimentary rock. Sedimentary rock. 3, we can have also, sorry, it's not sedimentary rock per se, actually it's sediment because it's a rock cycle. So please understand it's what is sediment that are being accumulating there. Number 2 is sediment. And then sedimentary rock, we have got the sediments are now forming sedimentary rock now at 3. And then at 4, we can say at 4, we can talk about the metamorphic rock. Metamorphic rock. And then at 5, this can also be shown by what 5 can represent, or it is shown the magma, and then we can also maybe say it can be what? It can be lava. So these are the things that we need to understand there to say that those are the 3, those are the 5 items that are shown on question in terms of the rock cycle. We have got our rock cycle there, which is actually shown as it is on this diagram there, the igneous rock. And then we have got the sediments that also accumulate there, which will also be cluster lined and compressed to form sedimentary rocks. And then eventually we can have the metamorphic rock, and then the lava, which is shown there. Briefly explain the difference between magma and also igneous rocks. Question 8.22. We can say that 1, magma is melted rock, is what melted rock, is what melted rock, and then it's a rock that forms when magma cools down, is a rock that is formed when magma cools down. It forms the igneous rocks. It's a rock that is formed when magma cools down, and then it is what melted rock in terms of magma. And then we can go to the next question. Sorry, let me just check again. It seems like, where's question 8.3? 8.3. Question is just okay. Let me just follow it the way it is. Number 9. Question point 9. It is mining in South Africa. Mining in South Africa, conservationists have realized that instead of fighting against mining operations, it is more effective to work with the mining companies to develop programs to restore the environment to its original condition. Give two reasons why mining operations never stop. Why mining operations they never stop. One, it generates revenue for the country. Mining generates revenue for the country. That is one very important thing. Also, it creates employment for the people by creating employment. Creates employment for the people. Creates employment for the people. I think that is quite true that we can know that uh, it is actually providing employment for the people. And then we can also maybe say that it provides opportunities for what? For further research and development. Provides opportunities for scientific and technological research. Scientific and technological research. That is also very important. We can note of that. It provides employment for opportunities for scientific and technological research. We know our technology is advancing, hence we cannot live out of this development or artificial intelligence that we are living in now. Even right now, you can see we are talking about the use of this platform that we are using now. It is a program that it is an advancement that we are getting as a result of improvement in our technologies. Next question is saying, question B, conservationists are concerned about mining practice. The question wants us to say, give reasons why conservationists are concerned about mining practice. Why are they concerned about mining practice? One, it damages places with high value it damages places with high value in in tourism. It damages uh, we can say places or environment, places uh, with high value in tourism, with high value in tourism. That can be a reason. Also, it also it damages places of their cultural heritage, which is also a concern or conservationist. It also we can also talk about uh, waste products causes lots of air, water, and land pollution. There are quite concerns that we can also talk about. Even the natural damage of the landscape. Natural damage of the landscape. It's a concern that conservationists must worry about the natural damage of the landscape. The landscape is actually damaged. You find out heavy machinery is breaking soils, which exposes it to vulnerability of erosion by its various agents that we can maybe talk about, which are quite a lot: rainwater, wind, and even ice. And then question 9.1.2 suggests two ways in which conservationists and mining companies can work together. How can they work together? Question 9.1.2, they actually should be one. We can talk about what there should be a strict government laws that govern mining. We can talk about enactment or replacement. Let me just say growing up of strict government policies. Growing up of strict government policies that govern mining. That is one. Two, we can also talk about there should be laws to govern pollution. Govern pollution. Placement of laws to govern pollution. We can also talk about guidelines should be drawn up to make use of mining activities to make sure that mining activities they do not damage the environment and its surrounding community. That is another procedure guidelines must be put in place to make sure that mining companies do not damage the environment and their communities. Environment and its communities. Those are some of the plans that must be put in place in order to ensure that uh, these are put in place to make sure that they are also taken care of. As well as old unused mines should be restored to their original condition. I think it's quite a very other point that we need to talk about. Mining reclamation. Old mines must be restored to their original state after mining is done. So old mines must be restored. That is sometimes maybe planting, or we can talk about replanting trees or afforestation of trees in old mining areas, so therefore they cannot remain unuseful to the environment or to the people surrounding there. And then 9.1.3 list layers of the atmosphere. We can say one, we have got the troposphere, two, we can talk about the stratosphere, we can talk about three, the mesosphere, and then lastly we can talk about the thermosphere. These are the layers of the atmosphere that we can define. The layers of the atmosphere, the troposphere, the stratosphere, the mesosphere, and the thermosphere. Question 9.2, discuss what the influence of the following scenario would be on the atmosphere. The average temperature rises considerably as a result of global warming. Global warming actually change would follow, e.g., we can talk about snow will melt, and then the rivers may dry up, and the plants and animals would also suffer from what? From an increase in average temperatures. So basically we are saying one, global climate change will take place. For example, snow melting, melting of snow. We can talk about, for example, melting of snow, and then drying up of rivers, drying up of rivers, and then we can also talk about plants and animals suffer from increase in global temperatures, and the plants and animals will definitely suffer from increase in average temperatures, from increase in average temperatures. So these are some of the things that we must take care of in terms of the average temperature rise considerably as a result of global warming. Obviously, it will result in climate change or global climate change that you can see there, which obviously causes melting of snows, which we talk about coastal flooding. At the end of the day, rivers may dry up also. Rivers may dry up, and then at the end of the day, we would have problems that have to do with what? With kind of such things there. 10.1, why are stars seen as different colors in the sky? Which is life, it is birth, life, and death of stars. Why are stars seen as different colors in the sky? It is because the color of star is determined by age. One, Color of what? The color of stars. Color of the star is determined. I'm sure I remember that it is determined by what? By age, which we can talk about its life cycle. And then we can also say that the color of a star is determined by its temperature. Color of a star is determined by its temperature. Any of that can also be fine to say why are stars seen in different colors in the sky. The color of a star is determined by its temperature, so therefore we can see them by different temperatures. Draw a flow diagram showing the life cycle of a star using the following terms, using the terms below. So we can say 10.2. I can just write them quickly. I'm sure that if you can refer them in your notes, you can know, you know very well that we have got uh, the nebula first, and then we have got the prostar, and then we have got the blue star, and then we have got the red star, the red star, and then, I mean, it's red giant, sorry. You can put it as red giant, and then we have got the white dwarf. So that's how it is to say a flow diagram showing the life cycle of a star using the terms that are given here. That's how it should be like. The nebula, the protostar, the blue star, the red giant, and then we have the what? And then we have got the white dwarf. That is how it should be like. And then when you say this, you are actually ensuring that it is actually clearly done. It is actually well done when it is like that. And then we can confirm to say that all is done. Thank you so much for your time, classy, and I hope that you understand, and please keep on turning on your notification button because I'm going to come with the various revision segments or revision exercises and work, as well as teachers' personal handouts notes that you can as well benefit from. So please take note. Quite a lot of work is coming before end of the term. Thank you for your time and have a beautiful day. All the best. Don't forget to like the work. I'm sure that you can actually see this work is quite articulated and very straight to point. Have a beautiful day.